So far we have discussed amplitude scaling, the basic concept, and about the amplitude scaling of the basic test signals, the step and ramp signal. Now let us understand the amplitude scaling we'll do on some random signals of different pattern. So this is a signal, reference signal. Let us perform amplitude scaling, let's say 2xt. So here, to perform amplitude scaling, you have to pay attention to the amplitude of the signal at different instants of time. For example, you have to pay attention what is the amplitude of the signal at distinct points 1, 2, 3, 4 and so on. And depending on that, you will multiply that by the scaling factor. Here the scaling factor is 2. So it will do it like this. Okay. One, 2, 3, 4. So here at time 1, the amplitude of the signal xt is 1. So here it will be 2 because we are amplifying it by a factor 2. So this. At here there is an upward rise from 1 to 2. So here it will be from 2 to 4. Okay. This. Again at t equals to 2, there is again a downward decrease with a certain slope, and at t equals to 2 the amplitude is again 1. So again it will drop down and the amplitude will decrease to here 2. Okay, we are just multiplying the amplitude by 2 at each time instant. Again at 3 it increases from 1 to 2, again the reference signal. Here it will increase from 2 to 4. Okay, and again it will drop down from 2 to 1 here in the reference signal. Here it will be from 4 to 2, and the same way it will decrease from 2 to 0. Here it will 1 to 0, here it will be from 2 to 0. So this is the amplified signal, amplified version of this signal. So only you have to pay attention to the amplitude of the signal at different time instant. This, this, and then you multiply the same with the scaling factor. Here it is 2. So this is the amplified signal. So the same signal we scale down it by factor 2, that is x t by 2. So we have to do the same with the amplitude. We'll scale it, so 1 will become 0.5 and 2 will become 1. That will be the peak variation. So 1, 2, 3, 4 is 0.5, this is 1. So at the different points, at t equals to 1 the amplitude is 1, so it will be 0.5 in this case. Then at t equals to 1 there is a instantaneous forward increase from 1 to 2, so here it will be from 0.5 to 1. From 1 to 2 there is a gradual decrease with a certain slope, negative slope from 2 to 1, so here it will be from 1 to 0.5. Again it will follow the same pattern from 0.5 to 1 as here it is from 1 to 2, and then at t equals to 3 has a value 1, here it is 2, then it will be like this and this. So the same thing we have done here. Here we the amplitude at different time instants, we have divided them by the scaling factor. Okay, so here the scaling factor is 1 by 2, so we just done the same with the amplitude. We have multiplied the amplitudes at different time instants with the scaling factor. 1 became 0.5, 2 became 1, and the same pattern is followed. Pattern stays the same, only the amplitude it is decreased. So here we have another signal, and let us say we will perform amplitude scaling by factor 3xt. So again the concept stays the same. You have to identify the amplitude variation points and multiply it with 3. So here the peak amplitude is 3. So here in this case the peak amplitude will become 9, and then subsequently 2 will become 6, then become 3. Okay, so I am not exactly showing all the points, I am just identifying the signal variations, and at those points we will make the changes. So here it is 0, 1, 2, 3 and 4. So at 1 here this amplitude is 2, so here in this case it will be 6. Okay, then we will follow the same pattern. From 2 to 3 there is a gradual increase with a suitable slope from 2 to 3. So here it will be from 6 to 9. This from 2 to 3, here it is 2 to 3, here it will be 6 to 9 because 3 times. Then instantaneous drop from 3 to 2, here it will be from 9 to 6, and then at 4 there is an instantaneous drop from 2 to 0, so here it will be from 6 to 0. Okay, this. Okay, so only you have to identify the amplitudes and multiply it with the scaling factor. Here the scaling factor is 3, it is greater than 1, so here it is amplification. Just identify these amplitude points in the reference signal, multiply it with the scaling factor. Okay, 1, 2, 3 became 3, 6, 9 multiplied with 3. Okay, and we will follow the same pattern. The pattern here is the same in both the cases, only the amplitudes are either scaled up or down. So in the same signal, if we have to perform a scaling down operation, let us say xt by 2, then again we have to identify the amplitude points and we multiply it by the scaling factor, which is 1 by 2. So it will become 0.5, 1 by 2, 2 by 2, 1, and 3 by 2, 1.5. And it will exhibit the same pattern, So here it will be like this. Okay, 2 it will be like then from 1.5 drop down this. Okay, same pattern is the same, only the amplitudes they are scaled down by factor 1 by 2. 1 became 0.5, 2 became 1, 3 became 1.5. Pattern is the same.